Measuring with a vernier caliper is pretty straightforward as long as you understand how it works. And this particular vernier caliper has imperial and metric scales on it. So we're going to look at the metric version in this video. Well, let's have a look at the scales. I've color coded them. The yellow is the imperial scale. We're not going to look at that today. And the pinkish color is the metric scale, the number line. The divisions there are true. But the Vernier scale, blue, that's the one that gives us the accurate measurement to 0.02 millimeters and allows us to use a vernier quickly and accurately. Now, this is a close-up of the metric scale and the Vernier scale. The metric scale is fixed along with the fixed jaw, as you saw in the other picture, and the Vernier scale slides with the sliding jaw. We're going to have a closer look at the Vernier scale. Remember that the above scale, the metric scale, is a true number line. And if you see the 2, the 3, and the 4 on the upper scale, that is 20 millimeters at the large line to the right, and 30 and 40 and so on. The Vernier scale is different, and we're going to take a closer look at the Vernier scale. Now, this is important about the Vernier scale. Its purpose is to measure from 0 millimeters to 1 millimeter, which is a very small amount, in divisions of 0.02 millimeters. And we will use that in our readings later. But remember that it measures in 0.02 millimeters. So let's have a look at the brilliant yet simple Vernier scale. When they calibrating this, they make it 1 millimeter shy of 50 millimeters. So it becomes 49 millimeters. But there are 50 divisions on it. And if we do the math, the 50 divisions will represent 0.02 millimeters, and that's the accuracy of our metric Vernier scale. But the actual size of the divisions on the Vernier scale, we will again do the math, are 0.98 millimeters. That means they're 0.02 shy of a millimeter, and that's why the lines do not line up with the above and the below scale. Because the Vernier scale is 1 millimeter shy of 50 millimeters, it would have to be moved a whole millimeter to catch up. But each time it moves 0.02 millimeters, which is the accuracy of the Vernier, another line will line up. And it'll continue to the right until the final line lines up and we have moved 1 millimeter. Now that is hard to visualize, I understand. I'll make this little diagram for you, and you can see the black is the upper and is the metric scale, and I'm doing the Vernier scale in blue. And I've tried to make the divisions increasingly smaller. If we take that blue scale and move it to the right, the farthest left will line up first, then the second, third, and so on. So if it's the fourth, that would be 0.8 of or 0.08 of a millimeter. And in that way, we can measure very accurately. This is a little snapshot at the bottom here is when the Vernier is at 0. Both the zeros are lining up, and the black, or the metric scale in black, represents a true millimeter, and the one in blue is 0.98 millimeters. So you can see if the first one lines up, there's an additional 0.02 millimeters added to the measurement. And if the second line lines up, there will be an additional 0.04 millimeters added to the total measurement. And if it's the third line that lines up, there would be 0.06 millimeters added to the total. And we'll go over how we add them up in the steps to follow. The first step is to read the metric scale, the number line scale, the scale above. And it reads in 1 full millimeters. So we look and we're past the 2, and we read it at the 0 on the Vernier scale. So we're past the 2, which means it's at least 20, and we count 21, 22 full millimeters past the 20. So our first step is to get the metric scale reading, which is 22. Then we're going to add the Vernier scale. To read the Vernier scale, we have to look for the number that lines up, or the line that lines up with the Vernier scale from the metric scale. And you'll see in this portion of the video that it's to the far right, so it's almost moved an entire millimeter, and it's 0.94. We have the 9 and then a couple of slashes after it. So our total measurement, would be 22.94 millimeters. And it's as simple as that. 2 steps. You read the metric scale, and then you read the Vernier scale where the lines line up. We're going to look at a few examples here, 3. And let's just do these steps slowly here. And first, of course, is the metric scale, where the 0 lines up with the above metric scale. And we see we have the 10, and then 1 past there is 11 millimeters. Step 2 is the Vernier, where the lines line up. And we have to look carefully here. It takes a good eyesight to see. And we're looking at it lining up pretty close. There we go, 0.18. So the total is 0.18 millimeters. Remember, on the Vernier scale, that's only a decimal of a millimeter, so it's from 0.00 to 0.99, because if it was over that, of course, it would be on another notch, and we would count it in the metric scale. In this second example, we'll just put the steps as numbers and look at the 0 right where I highlighted there, and it's 17 full millimeters. And the slide, we're going to find it. You have to look carefully again, and we find that it's at 0.64. We got the 6, and then 2 notches after, lines up. On this one, I'll give you a little time to try work it out yourself, and remember to use the 2-step method and then add them up. And of course, the Vernier scale is decimal whatever lines up. Well, I hope you're right, and that's it for the 3 examples. I think you can see how easy it is to read Vernier caliper with the metric scale. So I got a little video on different ways you can measure with the Vernier calipers.
First, let's look at how we can use the vernier as a measuring instrument in the workshop. The vernier can be used in 4 different ways. They are outside measurement, inside measurement, depth measurement with the tail, depth measurement with the head.
So that's the 4 different ways you can use this vernier caliper to do your measurements and get the accuracy of 0.02 millimeters. So thank you very much. Hope you enjoyed this, and happy measuring.